Okay, so we were discussing Snowflake. Okay, so what is Snowflake? Snowflake is a cloud data warehouse. Okay, so that means in order to learn cloud data warehouse, we should know first of all there is something called on-premises data warehouse. Okay, yeah. So in on-premises, what are the on-premises data warehouse? Like Teradata, Oracle, Microsoft SQL Server, they call MS SQL Server or SQL Server they call. So like that. Okay. So these are all on-premises data warehouses. Okay. So Snowflake is a cloud data warehouse. So even on-premises or cloud, whatever it is, first of all, we should know what is data warehouse. Then only we can understand whether on-premises or cloud. Because when tomorrow when you are going to work, your job will be migrating from on-premises data warehouse to cloud data warehouse. So we should be knowing. Okay. What is data warehouse? Data warehouse means it is the place where huge volumes of data is stored. Okay, even before going to that, what is a database? Database is a collection of data. Yesterday we saw. Okay, so database is it's a collection of data. So from database only the data warehouse came. It means when the data increases too much, especially you see nowadays business is increasing. Okay, data is rapidly increasing and they want to store the data so that based on the data they can come up with some ideas how to improve the business. So they started storing. You take see anyone, any business like insurance, banks, even telecom companies, or even travel, they all will store the data. Okay, but how much time they store it differs. For example, insurance companies and banks may store like 10 years, 20 years, 30 years. And telecom companies they don't need 10 years, 20 years. Okay, they may store maybe 1 year, 2 year. Okay, and travel companies, yes, they do will store like 1 year, for example, flight reservations and all. So yeah, so based on what type of business they are doing, how many years they store that differs, but everyone is storing the data accordingly. They send alerts to the customers for any new offers and all. For example, banks will send credit card loans, pre-approved loans, all those things, right? So that is based on our transaction history. So basically, the point what companies understood is by maintaining the data, we can improve the business, by sending some promotions, some offers to the eligible customers or the prospective customers who is maintaining such a good balance or credit record. Okay, cool. So database is basically a collection of data, but when the data increases too much, we call it as data warehouse. Okay, data warehouse in plain term is called like go down, right? Rice go down and all. Municipal corporations they'll maintain go down. So this is data. So this is called data warehouse. Okay. So what do they do with that data warehouse? They will use it for reporting purpose. Okay, means they will generate some reports to analyze. For example, take Reliance Smart. They can identify what are all the they have many stores, right, all over the India. So in fact, they do the forecasting and study. Okay, what are the branches which are doing good, and what are the branches which are not doing good, everything. And in fact, not only that, what are the items that are being sold most widely, and what are the items which are not being sold, everything they will have reporting accordingly. So the items which are going, most frequently, they will have more stock of that, and the items which are not going at all, they may even reduce the how much stock they should maintain in that store, like that. So yeah, everything based on reporting. For that purpose only they will maintain the entire history. Okay. Okay, so since we know the database, what is database? Database is a collection of data, okay, which stores the data in the form of rows and columns. Initially, everything started with Excel sheet, but Excel sheet has limitations. Okay, what is that limitations? It can only store up to some 2 GB of data. It cannot store more than that, but data is increasing so rapidly. So they invented like databases like MySQL, okay, DB2, Sybase. These are all old databases, okay, MySQL, DB2, Sybase, and all. Of course MySQL is still now there because they are also, you know, coming up with new features and all. But there we have to add storage, we have to add computing and all. That's why the cloud came actually. In cloud you don't have to worry about storage is full or not, compute is full or not. It auto will automatically scale. Okay, fine. So when the moment we say databases, okay, so in the database all the data is stored in different tables, right? So how to retrieve the data that is there in the different tables? Because if you see the customers data will be there in customers table, and products data will be there in products table, and different data will be there in different tables, right? For example, I will tell you, employee data will be there. For example, employee ID, employee name, dpt number, salary. So employee data will be there in employee table, and dpt data will be there in department table, dpt number, d name, location. So employee data is there in employee table, department data is there in department table, and similarly some other data will be there in that respective table. But our report, generally how our reports are not just only an employee data, and our reports are not just in department data. Our reports, how they look like, for example, I want all the employees who are working from Hyderabad location. What is that? I want, I mean, actually I want means the top level management, they want to see who are all the employees working from Hyderabad location. I want to see all the employees who are working from Hyderabad location. So how do you get this data? This is called report actually. Similarly, the retail store you take, supermarket. I want to see what are all the items that are, most frequently sold across stores or across cities. So in such way, this is just simple example just to make you to understand. Okay, I want to see all the employees who are working from Hyderabad location. Okay, or I want to, for example, another. I means who is this I? The top level management, the management. Okay, I want to see which are all the departments which are most paid. Which are all the departments which are most paid? Means department names you want. Okay. I want to see in which departments most of my amount is going. Maybe in the form of salaries or whatever it may be. I want to see which are all the departments where most of the amounts are going. Which are most paid means, yeah, where they're investing most of their amount or where their amount is going. So but you see the department name, actually they want department name. That is the easy to understand, right? If they say just 10, 20, 30 department numbers, I mean what is the 10 and 20? So department names, I want to see which department, like sales or marketing or production or HR, or which department it's going. So they want to see accordingly. Management want to take some decisions to reduce the cost or to implement whatever they plan they have. Maybe they may do cost cutting there to to improve the company, or they may replace some employees with experienced employees with less experienced employees. Or see, here also they can, I want to see which are all the departments where least amounts also paid. This is also possible. This question is most paid, other question is least paid. So they may want to improve that particular department by having additional employees. So they do reporting in every angle. What is their purpose? Their purpose is to improve. Okay, so if what they are doing right, what they are not doing right, they will see. If they're not doing right, they'll improve. If they're doing right, they will see how they can even better improve. So like that. So in both of these two queries, your data is not there in one table actually. So your data is there in two tables, because here you see the department name is there in the department table, and employee details are there in employee table. In the first query, Hyderabad, okay, I want all the employees who are working from Hyderabad location, and Hyderabad is not there in employee table. Okay, Hyderabad, where it will be there? It's there in location. Where is this location is there? It's in department table. So that's why. So we need to know how to write queries just by reading these, requirements. Very, very simple. Okay, I'll make you simple. So no need to worry. Here, the point I'm making is whatever data we need, it will not be present in one single table. It may be, not maybe, it will be present in different tables. It may not be two table, it may be three table, four table, five table, or even 10 tables also in real time. But you no need to worry at all. You just need to know how to join those tables, you know, and how to get your data. Okay, that I will tell you when discussing the joins. So yeah, so that's why all the tables are related with some, primary key, foreign keys. Okay, primary key, foreign key. That's why it is called relational database. That means in database, our data is there in multiple tables, and those tables are related with primary key, foreign key, and that's why it is called relational database. Okay, now actually, what is the primary key for this employee table? Generally, the column which is unique and not null, right? So yeah, employee ID.
Employee ID.
Yeah, what is the primary key for department table? Department table.
Uh, Department number.
Yeah,
I mean name
department
number.
number. Department number. Okay, so because in department table, department number should be unique and it should not be null. Similarly, for an employee table, employee ID should be unique and it should not be null. Okay, so yesterday, as I said, foreign key means something which is primary key in other table, but when it's present in a different table, for example, you see department number present here, it will become a foreign key in this table. See, department number actually primary key in department table, but it's present in the employee table also. So it will become a foreign key. Same thing, and a citizen of one country and he present in another country, he will become a foreigner there. For example, we are Indian citizens. If you go to America, you will be a foreigner. For example, American citizen comes to India, he will be a foreigner here. Same thing. A primary key of one table, when it's present in another table, it will become a foreigner there. That's why it is called foreign key. Okay, now the most important thing. Why do we have the common columns? Why the department is here and the department is also here? Why should we have common columns? Anyway, we have here, right, department number. Of course, one thing you can say is that yeah, it's always makes sense if you have department number in employee table also, because we will know this employee ID, we will know employee name, we will know his department also, we will know, and salary also we will know, of course, and whatever may be like date of joining, any number of columns you can add, date of joining or hire date, whatever it may be, or manager name. So you can add any of the columns, but I'm just telling why do we have department number in employee table while it's already present in department table. Why? Because we should, I mean, was common sense answer is yes, it makes sense. Okay, if we have a department, because it seems like we have all the details of employee in employee table. Obviously, if you have department number, okay, we know, okay, this is the employee, this is his name, okay, he works for, some sales department, this is his salary, this is his joining date, and this is his manager name. So we'll have all the details. But if it is not there, let's say, then there is a question, which department he works. He has all the details, but this detail is missing in that table. Which department he works? So So if you have all the information related to employee, yeah, that will be meaningful information. But even more important than that is we should have common columns so that we can join two tables. See, in employee table, department number is there. Department table also department number is there. So since these are two common, right? These are the common columns in these two tables. So using common columns only we can join. If you want to join two tables, there should be a common column based on which we can join. That is the purpose. That's why, okay, they always keep some common column, because without common column, how can we join? For example, you see, you joined the session Snowflake. I'm training the session Snowflake. What is the common feature between us? You want to learn Snowflake, I want to train Snowflake. So that Snowflake concept, okay, I want to train, you want to learn. That mutual interest is there. So we met. Similarly, if you want to join two tables, there should be some common column. Otherwise, how can you join? For example, if you want to have location, for example, the first question, I want to have all the employees work in Hyderabad location. How do you get location? You have to join with this table. Then only you can get location of the employee. But how do you join if there is no common column? So common column should be there. Okay. So that's why in real time you may give any number of tables, that doesn't matter. We need to see what is the common column among those tables and we should be joining that. That's it. Very simple. Okay, so that is the key actually. We know even in the interview he will ask different, he will give different tables. I mean, that is the complex he can give. Okay, I want to get so and so data. How do you write? Then you have to see what is the common column and you should join. That's it. For example, I'll write, see, one simple query. See, this is the question, right? I want all the employees who are working for Hyderabad location. Okay, I want all the employees. So select e dot star, or I mean e dot star. Why it's advanced right of writing queries. But okay, emplo or emp dot star from emp table, right? Okay. So join, you have to write like this: join DPT. Okay, where emp.dpt number equals to dpt.dpt number and location equals to Hyderabad. You have to apply this filter. So what it will do is it will join these two tables. Okay, this is the join condition. This join condition is based on what? Department number. Why department number? Because that is the common column. Okay, and what is another condition? He should be from Hyderabad location. So you have put another filter, location equals to Hyderabad. That's it, simple. So you will get the employees from Hyderabad location. Okay, and what details you are fetching? Employee details. See, in select whatever is there, that's what you are fetching. EMP dot star means actually employee table fields, all fields. I put star to indicate that I want all fields. All fields means what is there? Employee ID there, name there, department number there, salary there. Okay, date of joining, when every detail of the manager I will get. And who are those employees? They are working from Hyderabad location. So like that. So here I have join. Actually, this join means actually it's inner join. I mean, in the beginning you can write inner and all, but once you're experienced, you join and inner join both are same. Okay, so don't worry. Sometimes in the interview they will ask just to trick you, not trick you. You see, just to know whether you are fake or not, or whether you are genuine or not. What is the difference between join and inner join? We will ask. And he will see this side, that side. Just he will think. He will think a lot of things just to say, what is this? What is this inner join? My sir did not say. My sir said only join. He did not talk about inner join. Or my sir said only inner join. He did not talk about join. Generally, people will say they don't say join. They will say inner join. They will tell because that is textbook. Okay, but if you're experienced, you just use join. So my sir did not say inner join. He said only join. Or my sir did not say join, he said only inner join. They'll think something in the interview, they will tell something. Then we will know, okay, he is not working employee. Okay, inner join, join, both are same. Okay, fine. So anyway, we can easily find out whether a person has already experience or not, or whether he has already worked on, you know, on databases or data warehouses or not. Yeah. Okay. Or sometimes, in fact, I give many interview support for the US people. Theory, everybody will answer, okay, through some proxy or something, something, something. But they interviewers, they'll ask, can you please say, they will give simple query like this, okay? Can you please write? They will tell. That's it. He cannot write. He cannot write. Okay. So because he don't even know the SQL writing. So for example, you see, they will write like this, select star. Okay. From EMP. Somebody may help through proxy, let's say, then EMP, then he will write DPT. Okay. Mm, like this, he will write. Okay. Join. So just by seeing this, we will know. Okay, he is fake. Okay. So yeah, like that, we can easily identify just a few lines. The moment he started writing on the notepad, we can easily figure it out that you don't have any experience. Because if he's already having experience, you don't write like this. Okay, this is blunt mistake. Because anyway, once you start practicing, you will know. Here, star means, okay, you can practice all these things later. Of course, I will also show. Star means what happens? It will bring all the columns from these two tables. Employee table, department. It will bring all these columns, and these columns also it will bring from both the tables. And another thing, he did miss here comma. Even he can write query like this, but here he missed the comma here. When you are mentioning two tables, you should have comma here. So like that, okay, we can easily find out whether the person has experience or not. But if you learn from, not only learn, if you learn from real-time employee and you practice SQL thoroughly, then nobody can find out. Because only way we can find out is theory. We cannot much find out anybody because nowadays proxies are famous. Even while answering question, somebody is googling and giving answers. So, but while writing queries only, we can easily find out. Okay, whether he is fake or experienced or not. Okay, fine. So in this way, you can easily write. Okay, so that is about primary key means unique and not null. Foreign key means what is that foreign key? Foreign key is a primary key on table. When it's used in another table, it will become a foreign key. Okay, fine. So then next, database objects. Okay, what are database objects? In any database, there will be tables, views, okay, stored procedures, triggers, cursors, materialized views. Okay, so tables, views, stored procedures, triggers, cursors, users, databases. Okay, so like this. Okay, these are all called, okay, database objects means anything that you have in the database, it's an object. Okay. So okay, then what is this table? Table means it's the object which stores the data. How it stores the data in terms of rows and columns. Okay. Table is a data. What is a table? Table is a database object which stores rows and columns. Which stores the data in the form of rows and columns. What is a view? Anyway, we're going to have detailed discussion on views and materialized views and all. Okay, so that is important even for the interview. I'll tell you a view actually. What is a view? Actually, we load the data into tables, right? But in order to use the tables for reporting, we directly don't access those tables directly. We create views on top of the tables, and those views are actually accessed in the reporting. Okay, so I'll tell you how to create views, what is the purpose of the views. Okay, those are all a detailed discussion on that. And of course, remaining all other database objects like stored procedures, triggers, cursors. You just need to know, that's it. Users. User means, for example, when you join a company, a user will be created for you in Snowflake. Your user, maybe your username is maybe your employee ID, or your based on your first name, last name, they will create some user for you. So that's it. And a database means there will be some database created on the Snowflake to store the data. So anyway, these all will come to know once we log into Snowflake. Okay, so yeah, those are all database objects. Okay, now till now you know about what is a database, what is a relational database. Okay, so what is primary key, what is foreign key, and when coming to the database, what are the objects within the database like tables, views, stored procedures, cursors, triggers, users, databases, schemas. Actually, there is another term called SCHEMA, schema, materialized view, those things. Okay, yeah, maybe materialized view. So yeah, these things. Okay, fine. Now we will be discussing data warehouse. What is data warehouse? It's the place where huge volumes of data is stored. Okay, till now we saw things about database and relational database, primary key, foreign key, database objects. And that when the database increases means when there is more data, it is called data warehouse. So data warehouse is a place where huge volumes of data is stored. So that is a data warehouse actually. Okay, so data warehouse is a place where huge volumes of data is stored. Okay, and we have already seen what are the on-premises data warehouses and cloud data warehouses, right? I'll ask you a simple question. So tell me what are the different data warehouses you know? I mean cloud data warehouses. You see, everybody can answer. Okay, in fact, everyone can answer immediately. This is a definite question in the interview. Everything I'm asking is the interview question. Tell me what are different cloud data warehouses you know?
Redshift, this is Snowflake,
Redshift, Azure,
Azure,
Mm-hmm. Tell me again. Redshift.
and Redshift, Snowflake, and one more thing is BigQuery from GCP.
Okay.
Azure Synopsys.
Okay.
Azure, AWS.
Don't tell AWS. What is AWS? AWS is, is a cloud.
Sorry.
Okay. See, we should talk clearly and correctly. When we say about data warehouse, we should say, in fact, we should say clear statement. When he asked like that, you should say that, yeah, I have worked on Snowflake and AWS Redshift. Like that, you can say two clouds. Actually, why he asked what clouds you know, he just want to know which clouds you have worked on. Okay, you can clearly say, yeah, I have worked on Snowflake and AWS Redshift, or you don't even mention AWS. I have worked on Snowflake and Redshift. Actually, Redshift is AWS product, so you can say AWS Redshift. Or I have worked on Snowflake and Google BigQuery. Or I have worked on Snowflake and BigQuery. Like that, you can tell. Then he will say, "Oh, is it you got BigQuery exposure?" Yes, yes, like that. Okay. Yeah. So yeah, I have worked on Snowflake and Redshift. I have worked on Snowflake and BigQuery, like that. No need to tell three, all three. Okay, because you must be trying only with some 3 years or 4 years experience. So you can tell Redshift, Snowflake and Redshift, or Snowflake and BigQuery, or you can tell Snowflake and Teradata. Some on premises you can tell. Okay, I have worked with Oracle and Snowflake, Teradata and Snowflake, SQL Server and Snowflake, or MySQL and Snowflake. Anything you can tell on premises. Yeah, everybody. In fact, all your 3 years you must be working with some database. Okay, it may be on premises like MySQL, DB2, Sybase, Microsoft SQL Server, Teradata, Oracle. You must be working or Postgres. You must be working with any of these things out of all your 3 years or 4 years. So those databases you must know or you must be familiar with. Only cloud data warehouses you can say Snowflake and Redshift or Snowflake and BigQuery or Snowflake. I mean, you can just show all the 3 years or 4 years into Snowflake, but from different sources. What are those different sources? On-premises databases like Teradata, MySQL, DB2, Sybase, Microsoft SQL Server, those things actually. Okay, so yeah, so why I'm emphasizing is because this is a definite question, and even in the sleep, if someone asks, you should be able to tell. You need to tell Redshift rather than AWS. You should not say AWS. You should say Redshift, or you should say AWS Redshift. And similarly, you should not say GCP. You should say GCP BigQuery or Google BigQuery, or just remove everything BigQuery. That's it. BigQuery, Snowflake, and BigQuery, or Snowflake and Redshift. So okay, now once actually there is one more thing. Data warehouse is a place where huge volumes of data is stored, right? Okay, but before storing, there is called data warehouse design. Actually, these are little advanced. Okay, but still similarly, you see here also you will have database design. Actually, database design. In database there is database design. Okay, in data warehouse there is data warehouse design. Okay, what is this database design means? Tables DDLs creation. Okay, what should be the primary key of a table? What should be the foreign key of a table? Whether it's a null or not null. Okay, and what should be the data type of a table? I mean column. Data type is for column. And what should be the length of a column? These things will be decided in the database. What is the tables are there, right? So for tables they will decide. Okay, that is called database design. Okay, in the database design, they will decide the table details. For example, here employee is there. So they will decide, okay, what should be the primary key for this table and what is the data. Okay, these are the columns. Okay, what should be the data type for employee ID? What should be the data type for the employee name? What is the data type for department number? Whether it's a null or not null. Okay, so and whether it's any constraints, all these things they will decide as part of the database design. Okay, so similarly, there is something called data warehouse design also when we are creating data warehouse. Okay, in the data warehouse design, there are two things: star schema, and another one is Snowflake schema. You see, this is what I said. Many people will get confused. This Snowflake with this Snowflake schema. Okay. You see, this comes under data warehouse design. If you see many job descriptions, a candidate should be familiar with database design or data warehouse design and the different schemas, okay, and dimensional modeling, like that they will mention. Okay, so these are all the dimensional modeling, the star schema and snowflake schema. Okay, so these will be discussed under data warehouse design. Okay, so dimensional modeling we call. Okay, so data warehouse can be designed in two ways, using star schema or snowflake schema. I will tell you what is this star schema and snowflake schema. Even okay, star schema means fact table surrounded, yes, surrounded by denormalized dimension tables. That is star schema. Snowflake schema means fact table surrounded by normalized. See, very simple. That's why I wrote like this to give you easy understanding. Very simple difference. Star schema means fact table surrounded by denormalized dimension tables, whereas the snowflake schema means fact table surrounded by normalized dimension tables. Okay. So these are all the data warehouse basics. Especially if you are going first interview selected, second interview, for example, some senior guys comes with 15 years, 18 years. Actually, they studied these things and they worked on these things. So they will ask, okay, do you know star schema, snowflake schema, like that. They will ask what is fact table, what is dimension table. They will ask. Generally, the people who are working from last 5 years in the industry, they may not know this, because nowadays this is not widely used. Okay, star schema, snowflake schema. Okay, so but the experienced people still knows. And nowadays the emphasis is based on the subject only, because these are new tools, right? Snowflake, Redshift, BigQuery, they are just focusing on that only. They are not even going to these basics. Okay, so if you know Snowflake, they are just ready to take, because all that 1 hour or 45 minutes is spent in testing you on Snowflake knowledge only. Okay, interview will last max 1 hour. Okay, or sometimes 5 minutes. Okay, here and there, no problem. But they want to test you all your knowledge on Snowflake only. Okay, so that's why they don't want to spend on this time, because sometimes even if you don't tell this, if you're answering Snowflake, they want to take. Okay, that's why they are focusing on that main topic than these things. But you must know, if you know, always it's good, right? It's like, you did not give them chance that he did not answer this question. So it's better that you know. Okay, star schema. Star schema, what is star schema? Fact table surrounded by denormalized dimension table. Snowflake schema. What is that snowflake schema? Fact table surrounded by norm. So now do you think snowflake schema is different from the course we are learning? Our course is Snowflake. What is that? That's a cloud data warehouse. What is the Snowflake schema? It's a data warehouse, one of the design. You got the understanding? What is this Snowflake, and what is the Snowflake we are learning?
Yes, Krishna.
Yeah, because even a few years ago, when I see Snowflake, what is this Snowflake? Is it Snowflake schema, like that? I was thinking. But later I understood that Snowflake is the new data warehouse that is coming to the market. Okay, people from data warehouse background, they know Snowflake as the Snowflake schema. but this Snowflake is different. It's a cloud data warehouse. Okay, cool. So now in Star Schema and Snowflake Schema, we heard two new things: fact table and dimension table, and of course the another term, normalization or denormalization. So we need to know what is this fact table. Fact table or fact data they call. Okay, or sometimes they will call what is fact. Okay, fact table or fact data or what is fact. Okay, they can ask in any way. Similarly, dimension. What is dimension table? What is dimension data? So like that they will ask. Okay, so later on we will discuss what is normalization. Actually, all these things are there in my YouTube only, different classes. Okay, under data warehouse basics, we have discussed. You can see if you want. But anyway, this is also recorded, this session. Normalization and denormalization. Okay, I will tell you. Any of you from any of you studied data DBMS, maybe in your degree or anywhere? DBMS, database management systems. Any of you studied Harika or Monica or Durga Prasad?
Yeah, Krishna, I had studied in MCA, in my MCA, right? Both
Yeah.
DBMS and as well as database design. Yeah.
Okay, cool. What about you, Harika and Monica?
Yes, Krishna, I studied in my BTech,
Your which group?
DBMS,
CSC only.
CSC computers.
Okay. What about you, Monica?
Yeah, I studied in my degree.
Oh, then we can easily understand, right? Whatever I'm telling. I mean, maybe facts dimensions. This will be studied only in data warehousing, but remaining database, those are all covered under DBMS. Okay, facts dimensions will studied only in data warehousing. Okay, so okay, now I'll tell what is the fact data. Okay, facts means in any table there is numerical values, right? Numerical values, that is called fact. For example, sales, quantity, commission, revenue. These are all some numbers, right? Number data. Numerical data is called fact data. What is fact data? Numerical values. Numerical values is called fact data. Numerical values are measures. Actually, they call it as measures. Means measures means here numerical values, numbering. And what numbering means? How much is the sales? What is the quantity sold? What is the quantity ordered? Or what is the balance left? Okay. So what is the total sales? Or what is the total salaries? Anything that number, anything that refers to number or quantity sold or quantity left, quantity ordered or total sales or average sales or minimum sales, maximum sales, any that numbering value. Okay, numerical values or measures is called fact data. Anything that relates with number is called fact data. Dimension data means description about fact data is called dimension data. Descriptions of fact data is called dimension data, or description of fact data is called, means, for example, you take pen. Okay, pen. That pen is one of the item or product in the retail market, right? Retail means shop. If you go to shop, item, there will be many items like pen, pencil, and so many items in the shop if you go to. So how much is the quantity ordered? Let's say take about pen only. How much is the quantity ordered? 10. Okay. And what is the total? What is the quantity? I mean, cost of each price? Some 2 rupees. Then 10. What is the total price? 20 rupees. Okay. So the 2, 10, 20, those are all facts. Okay. So what is the cost of each item? 2 rupees. What is the number of pens in the pouch or packet? 10. So what is the total cost? 20. So those are all 10 to 20, those are all fact data. Dimension data means what is the product? Pen. What is the color? White. What is the size? Some inches. Okay. So what is the ink? Red. So that dimension, these are all called dimensions. Means description about that pen is called dimension data. Means its color, size. So income, what is that color, size, and different whatever it may be. Okay, so those other than the number description, okay, about the product description, that is called dimension. Okay, and like manufacture, okay, where it manufactured, location, or when it manufactured, okay, time, okay, expiry date. So because in dimension there are different dimension, date dimension, region dimension, means it talks about location, it talks about the date, when it manufactured, when it's expiry, or where it's manufactured. All these things that describes about that product is called dimension data. Okay, so so in order to store the data, we need, of course, our data, we definitely need its cost as well as its right, because there are many pens coming, right? That is not the only pen, there are different models will come, different sizes, so like that. So dimension data is also important. Okay, so for example, you take employee only. Employee, if any department, employee salary. Okay, for if you have sales department, you will have commission, those things, or total salary, average salary, okay, or monthly revenue or yearly revenue. But where, what is the employee name? Okay, where from he, like location. Okay, and what is the department name. So these are all dimensions. So for anything, fact data will be there, means numerical data will be there, and a description about the fact data also will be there. That is called dimension data. Okay, now, so anyway, normalization. The other term we heard is normalization. Normalization means, actually we studied this in DBMS. Normalization or normal forms, like first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form, right? The same thing here. Normalization means in every field there is only one value, that is first normal form. Okay, atomic values. Anyway, you no need to worry about this. Nor I will tell you normalization, denormalization in simple terms, or the terms which will be understandable to the interviewer. Normalization means splitting the data into multiple tables is called normalization. Splitting larger table into multiple smaller tables. That's what, right? Normalization. Even in our BTech, one large table will be there. You will split that into small table. That is called normalization. Okay, splitting larger table into multiple smaller tables is called normalization. Denormalization means you don't split here anything. Okay, you will keep all the data in single table. That is called denormalization. Okay, all the data will be present in same table. Okay, for example, see here, employee table. Okay, so wait. Now we have classified this like this, right? Employee table, department table. I can also write like this. I can also get my data like this. See here, in one source only I can get employee ID, employee name, department number, salary, date of joining, manager name, department name, location. I can get all the data in one file only. This is called denormalized data or denormalized table. If your data is like this, if your table is like this, means where all the columns are in one table, that's a denormalized. Okay, and normalized means you can split this in such a way that if required you can join them together. So you need to see what is the common column you have to keep. Okay, department number. So you can divide department number, dname, location into one table. See this one, and employee data into another table. So this we have divided, right? So that is called normalization. Means splitting the larger table into smaller tables. Okay, using some common columns. At that time you have to keep some common columns. Otherwise, how can you join it? So splitting the larger table into smaller tables is called normalization. Okay, but keeping all the data in the single table is called denormalization. Means you're not doing any normalization. You are just keeping as it is. Okay, so that is called denormalization. Denormalization means you're not splitting the data. Okay, so you will keep all the data in the same table. That is denormalization. Normalization means you will split the data into multiple smaller tables. That is called denormalization. Okay, in the interview they may ask, have you worked with normalized tables or denormalized tables? You can just see, you can tell anything, but you should be able to justify. Okay, you no need to get scared. Yeah, I worked in both, because you're showing yourself some 3 years or 4 years, right? So in 3 years, it's not that you just worked only in normalized data, or in just all the 3 years you worked only in denormalized data. No, nothing like that. Yeah, I worked in both the designs. Okay, so I worked with some projects where they are using only normalized tables. And in fact, mostly the cloud data warehouse means the all the cloud, it do earlier, all the tables are actually normalized some 5 years ago, or up to 5 years ago, or up to 10, before 10 years. There is compulsory, they used to use star schema, snowflake schema, those things. Okay, they should have small tables. But in cloud data warehouse, I have seen some tables have 200 columns, 250 columns, because they least bother about dividing the table into smaller fields. Because in cloud data warehouse, it's a columnar data warehouse actually. I will tell you that in the architecture, columnar means you don't have to worry about how much big the each record is. You don't worry. So even if the table has 200 fields, 300 fields, we least bother about it. Okay, and earlier the approach is ETL, extract, transform, load. But nowadays the approach is ELT, ETL. This is also very important. ETL versus ELT. Okay. ETL means extract, transform, load. Extract, transform, load. ELT. Extract, load, and then transform. What is the difference, sir? only this T is right, L is middle. So here extract means, I mean, this is what ETL or ELT. This is what our job actually in the once we get the job. What we do in job is this ELT or EL or ETL. Means what is this? E for extract, T for transform, L for load, ELT extract, load, and transform. So our job is basically we extract the data, from different sources. Okay, so that is E part. Means you see daily we do many transactions, right? You take about your phone pay, not only phone pay, your bank account management. Sometimes you'll get the funds using phone pay, sometimes you'll get using Google Pay, sometimes Paytm, somebody will transfer Neft. Okay, somebody will transfer what else, some internet banking. Okay, RTGS. So whatever way they're transferring, everything is coming into your account only, right? So and sometimes when we buy something online we'll pay, okay, through that yesterday I said, right, that how do we pay electricity bills and all? Some third party apps they will use for the payment receiving, like BillDesk I said. So like that they will receive payments, right? So these are all sources where the data is collected. Okay, so from all sources we'll collect the data, and then okay, we collect it, so that is called extract. Extract means we extract data. I'm talking about the payment system now. Okay, so we extract the data. It may be from anywhere, phone pay, Google Pay, or even BillDesk, or whatever the desk it is, or some POS systems like credit card swiping, debit card swiping, that mission. So those are all source systems. We get the data, and then load means I'm talking about ELT approach. Load means we load the data as it is. Load the data as it is into table. That means you collected the data and you loaded the data. That's it. Your job is over. After that, for reporting purpose, we want to see how much money is credited day by day. We can write query because data is already there in the table. Or how much money is credited month by month. We can write a query because data is already loaded. Or how much money is withdrawn, means debited from the account. You can also write a query because data is already loaded. So that is called, what is that? That is called transform. Means after loading the data, you are doing this. Okay. So okay, the that is new approach actually, ELT. This is a new approach, ELT. Older approach was like this: extract, transform, and then load. What is this transform? They used to do filter any failed or duplicate data. So any failed or duplicate transaction they will filter. Means any unnecessary data they will filter. Means only clean and quality data they will load it into table. So they will extract the data from all the sources. Okay, and then they will transform the data. What is the transform? Means cleaning the data. Any failed transactions, any duplicate transactions, everything they will filter it, and then they load the clean the data. Once after loading, again we'll write the queries to report day wise credits, day wise debits, or month wise debits. So all the same thing. So here, I mean, generally sometimes they will ask which one is better, ETL is better or ELT is better, and you must say that ELT is better. extract, load, and transform. Extract the data and load the data. That's it. You can do transform only whenever you are querying. Okay, unnecessary transformation is not required. But here you're extracting the data, you're transforming the data, then you're loading the data. Okay, after that you're querying the data or not, we don't know, but still we are transforming the data. So actually here company says that transformation unnecessarily, why we are filtering. Maybe if that is required after loading, we can see it, because while filtering we are missing some data. It may be a duplicate data, or it may be some failed transactions we are filtering. But if that is there, at least we can know later how many times he tried. That kind of information we are missing, right? Yeah, it failed, but how many times he tried? Okay. Or if duplicate data is there, how many times, for example, we some fraud happened. Okay, some money withdrawn, so he will know at least how many times he withdraw that amount. So that's why companies are focusing more on not to waste or not to lose any data. Okay, so let us load the data as it is, so that may be useful for any analysis. So that's why people are giving more importance to ELT. Extract, load the data as it is, and then keep it. If required, we can transform it later. Okay, based on our requirement, we can write a query. Okay, so you should say that, yeah, I was working both. I worked on ELT as well as ETL. Then he will say, okay, which one do you better run? I think ELT is the better, because we have all the data stored in the table, so we can transform it and use it whatever way we want. Yeah, that's it. ETL versus ELT. Yeah, this question also comes, I mean, sometimes, but if you tell, you will get the impression. Okay, if you don't tell, you don't get the impression. Is it clear till now whatever we discussed?
Yes, Krishna.
Okay.
Yes, Krishna.
Yes, Krishna, I do.
Okay, yeah, this class I will upload. Okay, you can just have a look. But this is very, very important if you want to have a solid career. Okay, don't think about it may be useful for the next interview or next, but it will come in every interview in some way or other. Okay, if you are facing some 10 interviews, among that minimum 4 interviews they will ask. I mean, 4 interviews they will ask. Remaining 6 they may not ask. But why to lose that 4 interviews also? That is my question. Okay, you must know. If you want to build your career in data warehousing, you must know these things. Okay, so just go through once. Yeah, these notes and all. Okay.
Okay.
Yeah. Any questions?
No, Krishna.
Okay. Okay then. Okay, this is a very, very important class with respect to database, data warehouse. Okay, facts, dimensions, normalization, denormalization, ETL versus ELT. Okay, so you should be knowing anytime. I mean, you should not feel that these terms are new. That is my actually whole intention. Okay. Okay then. See you tomorrow.
Yeah, Krishna. Thank you.
Yeah. Thank you all. Take care.
Thank you.
Yeah. Yeah.
Thank
Bye.
you.